So this talk is called All Change, how the new economics of cloud will make you think differently about Java. And there's the door if it's the wrong talk for you. Yeah, right. So I have only 30-odd minutes, so 40-odd minutes. So we'll spend 30 minutes on this slide, and then we'll move on. So this is one of the standard IBM disclaimers. I carry this one around. It probably should be updated by now. The important bit to take away is that anything I tell you is for informational purposes only. Not really sure what that's ever meant, but there we go. Okay, right. So this is me, Steve Poole. I work for IBM, and I've worked for IBM a long time, since the last millennium. And I've been doing Java for a very long time. Most of that in my career has been Java at IBM. At the moment, I'm doing something else completely differently. I'm leading a development re-engineering team. I'm the lead engineer for a team of people that are re-engineering the way that we use our internal systems. So we have very large numbers of computers, and we're making them work in a cloud-like manner. And we're also working with our development teams to get them to move to this environment. Right? So you can see this is all timely for us. I do open source and things like that, but mostly I'm a DevOps practitioner, and you can ask me in a couple of years and I'll tell you what that means. Right. So this talk is intended to make you think. I hope when you leave this you'll be thinking differently, and that you'll be inspired to go off and play with some of the technologies that you know about. I'm not going to talk in any real depth about Docker or PaaSes or things. We're going to do this economics talk. Right? It's about something else. But I hope that you'll be inspired enough to go off and go, I need to learn some more stuff. I need to go play. Right? It's really important that you start to think about some of the things we're talking. Right? I'm going to be talking about getting it into your head, go off and practice. So this talk is about cloud economics. It's about a compute on tap. It's something that we've been promising the world for a very long time. It's always been, they talk about the network computing or something like that, but we're really, really close now. We have many instances where people are getting immense value out of compute on tap. The trouble is, as we're talking about it, is that with taps, you get water meters. There's the problem, right? None of this is for free. And how many people here have had water meters fitted to their house? Yeah, I have. It's a shock. I have a very large pond in my garden, which I used to fill up without any problem at all. And now I'm worried about how much it's going to cost me. That's the problem in a nutshell, right? So the metric that we're going to talk about is something like this. This is not the only one by any means. This is gigabytes per hour. You will find, as you start using cloud, or you may already be finding this, that you're going to have to make some decisions about cost, right? And one of those is this sort of thing, gigabytes per hour. There are others. You can do gigabytes per millisecond, CPU instruction count. All the providers are thinking about how they're going to make this happen, how they're going to charge you. The important bit is you're going to get charged for what you use, right? And you have to understand this, right? This is already having an effect. I told you about my pond, but it's actually happening. People are having to think about it. Some of you may already be thinking about it, but it's actually becoming more and more important that you are thinking about the consequences of this new world, right? And the cloud, well, it has a lot to answer for. So why? So we promised people, that's people in this room, IT people, we promised the world something fantastic. We said we can provide you compute on tap. And if we give you this, life will be so much better, which is good. And on the other hand, you have products, customers going, I need to get things done quicker. Always faster, always quicker. We know that. That's just normal business pressures. And these things have come together. So businesses have been saying, I need to do things faster. And we've been saying, we can do things to help you get faster. And this all comes together with this sort of stuff. So here's a typical traditional infrastructure, well-organized, well-structured bunch of kit, which you inherit and you do things with. Okay. that has to go. Well, physically has to go, but it has to be dealt with differently. And what the cloud says to you is, we can give you this virtually dynamic environment, right? You don't need to have IT staff. You don't have to worry about networking or whether your kit falls over. That all gets dealt with. If you've been using Amazon, you know it's just there. It's compute on tap. Right? You can have infinite scale. It's easy. You can take your code and you can host it on somebody else's environment, and all you pay for is what you use. Who would not want to do that? That'd be great, wouldn't it? And not only can you just pay for what you use, you can do it very wide. So you can do things faster and quicker. So I'll just say that again. You can take your code and you can stick it in the cloud and you can have as much as you want and you just pay for what you use. That sounds really simple. What's the problem with that? So let's measure this. Let's look at this a little bit. How quickly... Sorry, did I miss over a slide? No. So I talked about speed. How quickly do you need to get into production? So what's the pressure coming up from the business guys? What are they saying they want to achieve? Would you believe, and this is real, I know we have at least one customer who wants to do this and probably others. How quickly do I have to get my change into, whatever my change is, out into my production system? So this particular customer is a fashion retailer, and they have totally direct evidence that they can see that if they have something in their portfolio, in their catalogue, that matches something that happens on TV. So you're watching TV, there's some nice lady and she's got a handbag. If they've got one that looks like that and they can get that on the front of their store, their web store, and not just the item, but theme it, they can do that in under an hour, they make money, right? They have difficulty doing that, but they know that when they do achieve it, it makes a big difference, and so they want to do it more. And that's just the sort of the pressures we're getting, right? And the point is, we know how to do this, right? There's a whole bunch of stuff. You guys are talking, probably here you've gone to talks on Dockers and PASs, and you've probably wandered around the store and the showroom and talked to Red Hat and stuff. We're all doing it, right? This stuff is real. Right? We really can do this. You've gone on talks on DevOps and test ops. Why is all this stuff here? Why is this all relevant right now? Because it all comes together because we can make this happen. Right? This is the telling thing. 80% of all new software has been delivered on the cloud. Okay. It's good. Customers can get their stuff into to market straight away. They can get their ideas done. They don't have to worry about infrastructure or talking to ops teams to buy kit. It's really powerful. We can do all this. We promise this, we're delivering. Right? And if you think this is just about cloud, where you say Amazon, Rackspace, SoftLayer, take your pick, you think it's Google, you think it's public? It's about a thing called hybrid cloud. That's private. Right? The biggest growth in this place is the fact that this is so compelling, so possible, that customers are they're looking at their infrastructure and they're going, we can easily, relatively term, convert our infrastructure, our data centers to work in the same way. We can put OpenStack or Docker or whatever, on top of our infrastructure and get the same characteristics. So just think about that. This is where you work today. If you've got computing kit, tomorrow you'll be able to deploy to it the same way or similar style that you can imagine doing to Docker, to Google and Amazon and whatever, right? That changes things. So what that means is compute equals money. Sorry, what does that mean? I said before about gigabyte hours. What we've actually done here is enabled our businesses to think of infrastructure as money, and it works both ways. Right? So now they can just buy CPUs. Sorry, they can go off and buy a CPU for as long as they want, much as they want, and give it back. The net of that is the immediate consequences is not what you might think. This isn't your infrastructure, local infrastructure is going to diminish and it's going to end up in the cloud. Actually, something else is going to happen. So The calculation is this. If I can buy X amount of CPU for a year, if I can invest in one of these things, right, if I can buy some kit, then I can do something a little more exciting. I can buy 4 times that amount of kit over a quarter of the time. I can invest the same amount of money, okay, and I can get more. So if I can get more quicker, okay, I can deliver faster, right? And I can do that over and over again. So here's where it starts to get horrible. The reason this is horrible is we're moving to an industrial scale. Right? Our development processes, DevOps, etc., are all starting to respond to the fact that we're working in an industrial environment. Right? The deployment times, the speed of deployment, the amount of deployment that you're going to have to do is going to rocket. And that's where we're going to start talking about the economics. Right? But I want you to think about this. This is, you can't say, oh, I'm doing what I'm doing today, and I'm going to do it differently, in that I'm going to do it in the cloud. No, what you're doing today is going to change because you're going to do a lot more of it. Okay. So what can you put in the cloud? So some application patterns. There are millions of them, so I just picked a few. I have hardware, operating systems. I have my app. Maybe I've got the database on the same machine. I've got another configuration where I've got a couple of apps in the same database. Maybe I've got 2 sets of towers on the same thing. Maybe I've got 2 OSs running on hypervisor on the hardware. I mean, you guys make all this stuff up. We have every combination you can make. Right? Pretty much all of these things can go into the cloud. I've dropped the hardware off. You can take that pattern and you can go put it in the cloud. It's not complicated. There may be some restrictions on you, but you can move it. Right? The question is not whether you can move it. The question is, will these patterns of applications that you've created, will they work in this new environment? Do you get the characteristics from your current application that actually you need to get? How well do they scale? How well can you create them, stage them? How fast can you do all these things? Right? How long does it take you to get value? So if you've got all this fantastic compute power on tap, and it takes you 6 weeks to get your stuff set up in the cloud, then the answer is not as good as not as much value as you'd like. Business wants better. So I'm not going to compare microservices or services with applications, but I want to point out that again, these patterns exist. Why do they exist? Because they're relevant. They're relevant. They work to solve these problems. So that's why they're important to us, because we're looking at them from those points of view. So microservices. So again, just different set of patterns, but much thinner patterns, more self-service, right? Not necessarily all completely separate. You might have, that's how you construct your service. It's up to you, whether they're very thin, narrow, whatever. But the point is that actually with these services, there are some characteristics. So they tend to scale better. Right? Because they're smaller and leaner, they tend to start faster. And if they start faster, then you can get them, you can respond to responses, to requests. You can do those things fast. You can scale. That's really important. They're resilient. Right? So if one falls over, you've probably got another one locking around, so you can just route the work. It's not as bad. They're easier to put in multiple clouds and things like that because they're easy to deploy. And you can start to do simple things. You're in this industrial stage now. You've got lots of services. You can start to do things like Netflix do with letting out little updates and seeing what happens. Okay, you can put a little bit out. You can put a new version out here, a new version out here. You can do all those clever things about letting your code out into the wild slightly. You don't have to be big bang stuff because you've got a different design pattern. Quality tends to be a bit better because you've got simpler systems. That sort of comes for free. Design and development, simpler, less complex means quicker to value. And that's sort of what we say. Nice, simple things. I can tell my business, yeah, we can do that little thing, we can get it out. We can micro-improve it. We can get it out, we can get it out. Value. And the fact is because it's that shape, it's easier to deploy. The fact is, if you put a container around this, how many people here have used Docker? Oh, okay, thank you. Oh, sorry, just a quick pause. I promised I would do this. How many people here are left-handed? Okay, just check. You put your right hand up. Okay. I had a conversation with somebody recently about whether we were more left-handed or right-handed, and so I said I'd check. Okay. So where were we? Infrastructure as code. Another pattern. Bake everything into the container. Changes less, easier to deploy. Right? Because you can test these things locally. So it's cool. And those Docker images can come to you, the base images can come from your ops teams, they can be secure and compliant. That's great. So they're happy, you're happy. So containers, services, and cloud. New way of working. You know that, you're here talking about this stuff. Oh, sorry. But what does this mean for Java? Let's get down to some of the detail. So, in this new world, the major takeaway, Java's got to work, because we're talking Java, Java's got to work in a more constrained and metered environment. Very specific. You don't get the free-for-all. When you have infrastructure under the desk, it can run slower. Right? You can't put more memory in it, it just gets what you want. When you've got pressure on you to do faster things, right, and you're paying by the gigabyte, people are going to say, what are you doing with that gigabyte? What can you do to get more out of it? Right? So whatever the unit is, and these things are all going to change over time, you are going to be measured more specifically. Right? Somebody's paying for that, and it's probably not you. And if somebody's paying for it, they're going to want to go, what am I getting for my money? And that's it. So money is the important bit here. Money changes everything. You've got a measurable unit. The cloud guys are saying you can buy compute power in these units, and we will pay you. Sorry, you will pay me for that unit. And the person paying is going, really good. I'm buying a gigabyte for you, Mr. Developer, or for you, ops guys, to run this. What value am I getting? How much am I getting out of it? Real focus. Sorry. So, back to the tap analogy. If you've got a leaky tap, well, it doesn't matter if you haven't got a water meter. But if you've got a water meter, it makes a big difference. So the first thing that's going to happen to you when you move your application into the cloud is you're going to get a bill. And then you're going to go, how am I paying that much? How can it possibly cost me that? Or you're going to put your application in the cloud and find that it doesn't respond. And then you're going to go, I need to put more memory in. It costs how much? Right? That's what your business guys are going to do. You're going to do the same thing. They're going to come looking. Right? Wherever you put this code, and remember, this is the other thing to remember with the cloud is location moves. So not only are you going to be asked to justify how much your code, where your money's going, what are you going to get for your value, where's the code going to run? Right? It's going to run wherever it's the most economic. Right? Moment by moment, the only thing that's going to stop your code running in a different data center is going to be probably one or two things. One is going to be legal requirements. So there are things about where data is. Can you leave the country with the data? There are lots of legal rules that may go, you can't do this. You can technically do it, but you may not be able to do it otherwise. And also some sense about risk. How much do you trust the cloud provider? You know, he's really cheap, but we're not sure that he's very secure versus they're very secure and they're expensive. So those sorts of things. But the point being, your code can move everywhere. Right? And your code's got to scale better. Right? It's going to cost, so it's got to scale. Right? People are going to be giving you money, and they're going to be demanding that you demonstrate that you're getting the value that they want to see. Right? And the point is, as I keep saying, it's down to small units now. Right? So your code's got to be better. It's got to be better fitting. Right? It's going to be really scary. I've got this picture on my wall at work because it works really well. I have conversations with people, we look at the picture, we go, yeah, it's going to be really scary. Is it going to be that scary? Nah. Everything's going to change. everything you're doing is going to be affected. The way that you think is going to be affected by all these economics. Right? Every single piece of it, for good, for bad, you've got to start thinking about this and how it's going to affect you. So let's do a few examples. Let's go back to container-based. So again, this is just because this is something that we can deploy. So containers are good, aren't they? You can just deploy them. What happens if it's not a container? Does it matter? Well, not really, because your first lesson, deployment takes time and uses bandwidth. You're paying for bandwidth, or your company's paying for bandwidth. Now you're moving stuff. Whereas before, you might have a data center and the connection between you and those was a nice local area network. Now you're connecting to these things via a pipe that you may have bought, which is costing money, or you've got just a general connection to the internet, which is costing you money. You're using bandwidth. You've got to pay for every single piece of byte that goes down that. And believe me, your pipe, however big you think it is, isn't big enough. Right? I mean, I tell you, if you start looking at the traffic between the machines that you've got, between, say, where your source is and where your build engines are and all those sorts of things, you're going to be shocked by how much traffic is moving. And bear in mind, this is also economics, not only about things like putting SaaS products out, putting APIs out, which is the primary thing about we're talking about, but if you're doing build and test, then you're moving data, which you're going to be paying for. If you're using build engines in the cloud, you've got to move data in and out. It's going to cost you. It takes time. It costs money. And when you look at it from a land point of view, you start to realize that you're moving terabytes, and you can't afford to move terabytes even if you wanted to. So no unnecessary baggage. You have to remove this stuff. So what's happening? So modularity, Java 9 modularity, it's going to help, no doubt about that. It's all your unnecessary dependencies. Now, you know you have unnecessary dependencies, but it's never been a big deal. It's like, well, I've got stuff, but yeah, well, we use it occasionally. I've got that convenience piece of code. You know, we pulled down the whole of that 15 things out of Maven just for that one method because it was there. It was easy. And now you're going to have to think about, how much did it cost me? Well, your dependencies, are you getting the value out of dependencies that you want based on the fact that you're paying to move that code to a remote system? And even if you actually go, no, I've just got a POM and it says I want to use this thing, well, you may find that your deployment mechanism may say when it gets to the remote end, so you're using PaaS or something, you might find that when it gets there, there's a staging activity that goes on and that code is pulled down from the Maven Central or whatever. You may find you're paying for that as well. So the point is, you have to now think about the size of stuff. Are you getting the value that you want out of using that? Right? And ditto with OSs and stuff, distributions. How big are they? How much are you getting? You're moving the data. If you're sending a Docker image, right, and you take a base Docker image and you put Java and you've got Java on it and things like that, it might be 600 meg. And you're going, I'm moving 600 meg to run my 1 meg's worth of application. Right? So what are you going to do? So there are good things you can do to reduce the size of Docker images. There's lots of techniques for that. The important bit is you've got to think about it. You've got to start looking at it and going, why am I choosing Ubuntu? Should I be using PenOS or something? Because it's smaller, less dependencies. I'm paying for it. Right? You've got to get down to carry on. Right? So if you think about the fact that your app's going to be staged, you're going to use it, you're going to stage more of them, and then you're going to come along tomorrow or an hour and change it. So small. Carry on. It's not going to last very long because you're going to update it. Don't do big stuff because you're going to pay for it. Okay, startup times. I don't know what to say about startup times because I'm to blame. Well, me and that guy there and others to blame to a lot about this stuff over here. So how long do you want to wait? So we're talking Java. How long do you want to wait for startup time? I initiate it till my application is going. You know, how long do you have to wait? Unfortunately, not more than you want to. And so what you tend to do is you tend to create You have instances running preemptively. They're going to cost you money. It's not really what you want to do. What we need to do is find some way to make Java startup time faster. Yes. Okay, and while I'm thinking about it, in these new worlds of fast services, anything that happens during startup time is going to happen every time you start that application. So if it's not of value to you, we need to find a way of stopping it, because you're going to be paying for it. Java startup times. Java's famous for its startup times. And we've seen this benchmark, or this sort of style of benchmark. I won't call it, this is just me drawing a picture. But you must have seen these sorts of benchmarks where there is this warm-up stage, okay? And then you get to steady state, okay? Well, in our new world, there's no warm-up stage. You have to go straight to maximum value, right? So you need to start thinking about what goes on when your application starts. How often have you sat there and gone, well, we'll do all this at startup, cache things and get all things loaded because we're going to need it during runtime. And then you go, well, actually, we don't always use it during runtime. Maybe occasionally it doesn't get used, right? So now you've got to start thinking about how you're going to make that trade-off, right? You can change those things. Maybe you have services that only do it that way, and here's another service that does it a different way. And you make decisions about which one to use somewhere else. You don't put the code in your application because you've got to pay to move it, right? And other things. Now, the JVM needs to do things, right? The JVM has spent a lot of effort over time figuring out that we can do that up front, and that will save throughput cost. And in a lot of those, we're going to have to go back and go, why do we do that, and can we change it, right? So the interesting thing is what we change is going to be driven by the choices that you make over time as to what metrics and what cost value proposition you sign up to, right? So it's going to be an interesting journey. Oh yeah, so what happens about everything that happens at startup happens every time? Well, you must know this. I'm sure you've gone to talks and they tell you what happens to the VM loads. Right? The VM doesn't know what your application is going to do, so it has to provide a general purpose environment. Loads stuff up, tries to give you a general system. If I got stuff around, okay, runs your startup code, starts to get hints about what you're going to want to do, does some optimization, might do it multiple things, right? And all that happens every single time, right? Thing is, what we want is, what we're trying to get to is more of a ready meal. I want to go get it, heat it, done type service than I start with some basic materials and every time I cook it. We're trying to get away from that. So, if you've got container-based services, which is, so you create a Docker image. So you create a Docker image, you've baked everything in, you put it in the cloud, you start it, and it goes through the startup process and it jits things and it does all these wonderful stuff, right? And the point is, everything it does, it did before, it did during development and test, and now it's going to do it again, and you're going to pay for it. And you don't need to, or you shouldn't have to. We don't have, at the moment, a good way to capture that. Some programming languages out there have runtimes that allow you to bake that startup. Some of them are implicit, but the idea would be you want to get a running system and go, take an image, please. That's what you really want. It's not as trivial as that, but that's really what needs to happen. You've got to find ways, we've got to find ways of reducing this wasted effort. So let me just add a few more thoughts to this conversation. Do we need a JVM? So you've got a Docker image. And that Docker image, and I'll pick Docker as just being the example, but you imagine this, you're baking something that you want to be infrastructure as code, it's just going to run the same way. So what's the JVM for? Do I need that level of abstraction? Do I need to have class files and bytecode? Do I need to have them in the format they're in? Do I need them at all? Well, how about if I go straight to machine code? What if I could compile my Java code down to machine code, right? If I've got a Docker image running on x86, that image is never going to run on my mainframe or my power kit, right? So I'm not saying I want to get rid of VM, but I want you to think about, and we should all be thinking about, the consequences of where we're going. So there's some linker work coming in Java 9, and things are going to get better. But part of this is you coming back and going, this is what I want to do. And part of this is us socializing the fact that we have to have these thoughts. Okay, so more IoT, right? And depending on how long your service is going to last, then maybe there's no need for a JIT because there's no time to do re-optimization. Maybe it's not necessary. Anything that we do that doesn't get used or that we do repeatedly, you're paying for. And so we have to think about ways to reduce that cost. How much RAM does your application use? Well, so this is a simple answer. Whatever you tell me will be wrong because it's too much. Oh, let's have a test here. How many people use have used one gig or less in their Java application? Okay. Oh, one. Okay. This is an SE environment, is it? Yeah. I'm not talking small devices. How about what's the next thing? 4 gig. That's quite common. How many are using 4? Oh, cool. We're getting there. How about 8? Okay. Are there any bigger numbers? 16, 32? 16. God, dear. So 16 gig. Yeah. Wow. Going to pay a lot. People are going to charge you for that. That's almost one of the default charges is how much RAM do you want? You create an application and you go buy some space in Amazon or whatever, and somewhere there's how much RAM you're buying, right? So you've got to find ways to fit your application into less. You just got to do that, right? Because whether or not you want to, your business guys are going to go, no, you can't have 18 gig or 3 gig because we can't afford it, right? It's going to have to be less. So what are you going to be doing about looking at how your application is constructed? Because that's what you've got to do, right? You've got to go, I've got to deal with this constrained thing. And not only because your business is paying for it, but because of the personal thing that your manager's not going to sign it off, right? And he's going to be saying, no, you must do this, right? Oh, by the way, even if you do get him to add the charge, that's going to be multiplied by the number of concurrent instances that you have running. So it's not 4 gig, it's 4 gig times 10 or 100 or 1,000. So the bill goes up based on the number of things you're trying to run. That's not necessarily a bad thing because obviously you're profitable because you're running that amount of those months of services, but the equation is there. So you've got to go from big RAMs to lots of little RAMs. Multiple languages on the JVM. So this is a contentious one, I hope. How many people here have applications that use things other than Java for which they can find that language separately? So I don't mean Scala, actually Groovy works on other things, but basically, how many people have got applications where you're using a JVM and something else? Nobody? Wow. Okay, half-ish, one-ish. And I don't mean JavaScript in the browser and things like that, but basically you've constructed an application where you've got a set of programming languages. Okay. So it's interesting. So, and this is not to throw rocks at Oracle at all, but this is just life. There's been lots of effort to try and get other programming languages running on the VM, and they're not all as successful. Some of them are wildly off, mostly for technical problems, because you're trying to take a VM to get it to do something else, and that's difficult, and you're going through that abstraction layer. The point is that if you had an application where you needed to have a different programming language, you got value out of having a different programming language. That was the component you bought or whatever. Having on a big monolithic system makes sense. It doesn't cost you too much. But once you start looking at these services, you start saying, do you really want to do that? Because you're paying more, right? So there's some horrible statistics, like Node.js is 4 times faster than the one in the VM, and use more memory and stuff like that. But sometimes that's a consequence, and there are things you've got to think about. How is it that what you're doing, does it really need you to do this in Java? Do you need to start picking the right solution for the right environment and not get too precious about it's going to be just Java, right? Because it's about money, right? So a lot of this is all coming towards this API economy. So really, if you start looking at where the trends are, this is the really important thing. The API economy. What does that mean? You've got data, and I'll tell you this, we're just seeing this. If your company has data, then it's going to get externalized and monetized. Companies you would not believe, from sewage companies, guys who produce plaster, you name it, they realize that they can make money out of putting their data on the web. They're building APIs. And we all want to do that because those APIs are the things that let you build new services and you can make more money, right? So again, this is part of all the things that we're doing at the moment. This is what's driving it, right? And it's going to happen, believe me. Whatever API you think, whatever data your company's got, somebody will buy it from you. And if they want to buy it from you nowadays, they're going to want an API. So now I'd give you a different thought. So what makes a good cloud API? Well, one thing, so I've sort of fitted the terms into the alphabet just to make it slightly fun, but the bottom one is the thing that you might go is most important. What does my API do? Well, basically, you have an API that provides some basic thing. All the shiny widgets, it's not actually high on the buying decisions. Your APIs are your application, your API is going to get selected by a bunch of other criteria. It's going to get selected by availability. Well, 100% of course. You do have your application 100% available, don't you? Okay, you have to do that. Oh, by the way, are you telling the truth when you say it's available 100% of the time? Be surprised at how many people fudge. How much does it cost to use the API? What metric you're using? Can your user diagnose all the problems of the API? So these are all parts of the economics. You have to provide these capabilities. This isn't just about cost, it's also about design and engagement. What is it that your customers will want to see? You guys use APIs. How often would you think that if you were using, I don't know, a NASA API to get some data out, that you could have a chat with a developer at the other end? Well, you might just, but it's not something to do very often, right? So they need to be able to figure out how your application works and how to diagnose it and all those things. They are vitally important to the economy of your system, right? Oh, and by the way, the last one, are there people using your API? Have you got a community? You'd be surprised at how many APIs don't get picked up because you can't see who's using it. Right. So to get all this sort of stuff, you've got to build resilient APIs. You've got to have resilient applications. You've got to be thinking about scaling and failover and stuff like that. Right? It just gets you. So a few bits of advice. Get out of the habit of diagnosing problems with live systems. It's industrial. You have too many of them. Okay, you just have to kill them. Right? Everything you do may fail. Everything you're relying on may go away. Intermittently, mostly, but quite possibly permanently, but mostly intermittently. Everything goes. I/O. So basically, do as few as you can. Makes sense. Don't be, and time out quickly and deal with it. Don't be sitting there waiting for things to go on. I was in a talk here. Somebody was saying about, I think it was the new HD2E stuff. It was like, you've got 4 seconds to respond, otherwise the user moves off. Well, how about that with APIs? What happens if you can't get a response? Do you sit there and say, I'm going to wait the whole year? No. You're just going to go kill it and move on. Because most of the time, it times out because of something else in the system. right? Check everything. Everything that comes into you is not going to be well formed. You have to deal with that. You cannot assume that the person at the other end is your friend, and you definitely can't assume that you're going to get solid data. Everything has to check. You've got to do this. You've got to think about this. This is how you think about your applications now, is you're putting it into the Wild West. You're interacting with people who deliberately or by accident are going to do things you aren't going to expect. Right? You've got to get into the habit of thinking about retry. So every I.O. that you do, what do you do when it fails? So you don't want to have a try-catch thing that just go, oh, I.O. exception, boof. No. You've got to say, it got to this point, I was doing this event, I was triggering this function, and I got the I.O., I need to retry. You need to build retry. People are starting to write solutions for this and code that you can go take. We need to figure out which of these are important and start getting them into Java. But right now, you need to be thinking about how you're going to deal with these intermittent failures. Oh, this is me and my mother. You must have had this one. Yeah, you get the, oh, I can't use the computer. Oh dear, what's the problem with it? Well, it's not working. Okay, what's on the screen? Well, this blue thing, and it's got letters on it. Oh, all right, then I'll come over. Right? I'll come and give you my personal help. Right? I can't do that. You just can't do that. You cannot do remote debugging. You will never be allowed to log on to those remote systems. Right? It's just not going to happen. Okay? If it happens, it's really rare. You just can't do it. You won't be able to put debugger on it. You've got to deal with failing of problems using logs and traces and dumps. Right? And to be honest, a lot of the time, we're just going to kill it. The application fails, the service fails, you kill it, you create a new one because of these intermittent problems. You just deal with it. Right? You don't even bother tracking it down. You do statistical things to figure out you're getting the same problem over and over again. Maybe you do something. But the point is, you don't get to log in. Okay. And actually, there are some circumstances, especially during startup and things, where you may not even be able to get the logs. Right? You won't be able to get onto whatever has been captured for you because it failed at a point where it was still being instantiated. That happens a lot. So figure out how to get your data off the system because that's the most important bit. Get your logs off. And you're going to pay for it, but it's worth it. So I'm rushing because I've got 8 minutes left. So quickly, coming up to the end, why can't you keep instances around? That's what it says. Going, well, look, if it fails, just park it. And I'll come back to it later. Well, you can. It's going to cost you. And it's going to cost you more than just direct gigabytes in use thing. There's another thing going on. This is a snapshot of a Horizon dashboard, which is part of OpenStack. When you're deploying machines, you could have an infinite capacity, couldn't you? You could turn up and go, I've got my boss's credit card and I'm now going to spend it. Well, actually, what really happens is there's some sort of limit on that. And there's usually some way of negotiation that says you can spend all this amount of money, but within these limits. And this is just one example. This is just a snapshot of an OpenStack image. Environment where I've been given, I can have 8 instances running, I can have up to 8 CPUs, and I can use up to 12 gigabyte of RAM in any combination I want. The point is, that's all I've got. And what happens when I start going, oh, I'm going to keep that debug image around until I get around to it, because I start eating up valuable slots. I have limits, I start hitting them. Okay, so that has consequences. But I'm trying to explain, you've got to think differently about how you do stuff. And that change has got to get into the way that you look at applications. So you've got to think of industrial scale, you've got to think of failing all the time, you've got to think about the fact that you have very hard limits. Right? Whether it's gigabytes, whether it's dollars, you're still going to have these sorts of situations. And your application has to deal with it. And you need to feed back to the VM providers and others what problems you're having and what you want to see into Java. So, a bit of a whirlwind tour. It is all change. Everything you're doing, you have to think differently. Right? every bit of this has consequences to the way that you do business, how you create your code, how you think about it. Right? You can't just assume, happy path, I think is the term. Right? Happy path is now the unusual event. Everything's going to go wrong in some point, in some way at some point, and you've got to deal with it. Financial metrics, they are the things that bite you. We've all, like my water meter, we've all been affected by situations where you personally have to spend money on something, or you're going to be charged something. That changes your behaviour. Maybe you can't afford it, so you stop doing it, or you go, I will change my behaviour. I will buy, I won't buy 2 beers a night. I'll buy 1 beer a night because I can't afford it, or I won't fill up my pond every week. I'll wait until it gets down 6 inches before I fill it up. And those sorts of things. This is going to affect you. All right? Okay. You have to do all this. No choice. It's coming to bite you. And this is all in support of this, the API economy. All right? This is where we're going. All right? And you guys are on the journey with the rest of us, and you've got to change the way that you think about how you create your applications. It isn't so much about the shiny technologies and the cool things you can do. That's all good, that's value, but you have to think about this piece, right? So I would hope that you come out away from here a little bit more inspired, and that you're going to go do some play. Go sign up to PASs and things like that. Go play, get your heads around it, see what problems you can encounter with just those things. Shout about it, blog about it, Come to these events and go, I did what Steve said, and here's my reaction, and here's my results. That'd be really cool. So with that, I think I'm finished. Thank you very much. I have apparently 4 minutes for Q&A, and apparently only 4 minutes for Q&A. So sorry for the rush. It was the first time through. Do I have any questions or reactions? Or no? Okay. Yeah.
C++, right?
Sorry?
C++, right?
C. Yeah. 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 C++. I'm not sure if that's a question or a threat. Yeah.
Managing with Java all the timeouts, RAM usage, all those things is really difficult. What it gives you is the faster development time.
Yes.
And that basically takes it away.
There is no fixed answer to what I'm proposing. I'm just saying you've got to think about, do I do it this way or this way? Well, before you've had conversation, you've been thinking about, I'll do it in Java because it's faster or it's more resilient and I've got OO models and all that sorts of stuff. Now I'm just saying there's another thing you have to think about, which is your choices will affect your budget and directly affect your budget, and your manager can measure. Your manager knows gigabytes per hour and what that means. Yeah, that's the killer. Yeah. Yes, Richard.
Hey, how's it going? So one of the things you mentioned was slow startup times in user code. But this is not really an excessively bad problem, as long as you're not using terrible, bulky enterprise frameworks that do a bunch of runtime code generation in their startup, or give you a 10-second proof warm up.
So what you're saying is that if we... But okay, so so I think Richard's statement is don't drop the JIT when you're doing for startup purposes. Just drop all the stupid frameworks we've got. And I would accept that lean Java code is a very good thing to do. So pick cheap frameworks, that's for sure, or thin frameworks. But having said that, if you're JITting code multiple times and you're throwing it away every time, that's a poor thing to do too. Yeah.
Which side are you leaning towards? Because I'm sort of gathering that there was a little bit skeptical around cloud. That's my perception, maybe. It's personal, but which way? Are you warning or are you advocating?
No, I'm not doing either. I'm not warning or advocating. What I'm trying to do is just make you aware that these are things to think about. There are no solutions because it's an evolving thing. We haven't figured, the guys who are providing the capacity haven't figured out what the metrics are and how they want to charge you. And that's partly driven by they don't know what you want to do. And it's like when it becomes more obvious what your application shapes are going to be looking like, then they'll start charging. So the charging model is based on your usage, and we're at too early days to say what it should be. There's some really basic stuff that you're seeing, but it's going to change. So all I'm saying is you have to look at how you create your application just from a different point of view, right? And be thinking about it now, because it's going to bite you later on.
I thought you've got personal opinion.
Yeah, okay. Apparently my time's up, and I have no wiggle room. So thank you very much.